this is another version of hostile brothers, but this time in a triangle. So suppose we have a triangle with the known dimensions. A and B are the dimensions of that triangle, and then we want to make sure that all brothers or hostile brothers are located inside that triangle in a way that their minimum distance is maximized. So first of all, the formula for calculating the distance between each pair of brothers is the same, but now we need to make sure that the red dots are inside the triangle. Okay, so for this purpose I have to make sure that x is always between 0 and b, and y is between 0 and a and b are the input parameters, and also all the dots are below that specific line connecting A to B. Okay, this is the formula for that. Okay, so let's have a look at the Python code. Okay, so here you can see that the Python code is trying to do what. So at the beginning, the first tab is importing the required packages, and then we have to define A, B sets and N, and also I and J, and also the variables. So this part of the code is similar to the previous ones. So here you can see that we have to define 3 variables, X, Y, and R, and also some rules for calculating the minimum distance. It is a famous rule that we already used in the previous 2 hostile brother variants. And also C2 is the line specifying that we should always be below that line. Okay, and finally that's the objective function. So I run this part of the code as well. Okay, it is run successfully, and I specify A and B and the number of brothers here. Okay, so it takes a bit time to run the code because it's non-linear, and it's has 50 brothers. Okay, and also at the final stage, you can see here that how the brothers are allocated inside that triangle. If I change the number of brothers, let's say there are 10 now, so it will run more quickly. And if I run the code, you can see that how they are scattered inside that triangle. Okay, so you can change it as you wish for your own purpose. Thank you very much.